everybody. Just wanted to welcome you back to videos. I know we haven't had a new video since March 26th, I think. So we're back to having some new material because we've been kind of on a pause or a catch-up for some of those people who needed a little bit of time to get there. And from here on out, we will keep a relaxed pace, but we are going to kind of, continue with notes most days from Tuesday through Thursday. So here goes. Hyperbolas number 3. So you spent a little bit of time, hopefully yesterday and today, reviewing some of the work from March 25th and March 26th that had to do with the first 2 days of hyperbolas, and here's our third and final day of hyperbolas. So there's a couple things the notes mention that is important for us to distinguish. Number one, if you are somebody who got the hard copy papers, I'd just like to remind you, as I already told you twice, that the dates on any papers in April will probably not be matching. As you can see, we are doing this on a Thursday, but nowhere near April 9th. We've made those pacing adjustments that we needed to once the e-learning continued. So, in reminders, what we want to talk about is the differences and connections between ellipses and hyperbolas, because they become especially important when we're writing equations, which is what our task is for today. So in an ellipse, when the equation was connected with a summation symbol, a was always bigger than b, okay? And c squared was equal to a squared minus b squared. So that's what you've been working with. But in a hyperbola, things are going to change. First of all, a is first, right? And we should know that from our graphing expeditions the last few days, and likely, and therefore under the positive squared term. But we also need to recognize that this formula changes. Whereas in an ellipse, we have a subtraction for the focal relationship. In a hyperbola, the focal relationship is a plus. But one of the things it says is, what is a pattern you notice about these focal relationships above and the standard form? And it says look at the bottom of page 2 to help. So we'll kind of give you that option, and I'm going to put that on the screen for us right now. So if I take page 2, which is just on a different color because I'm choosing from a different physical copy so you can see both at the same time, you're going to notice that in the ellipse equation you have a plus, whether it's horizontal or vertical, but in the focal relationship you have a subtraction. In a hyperbola, you have a subtraction symbol in the original standard form equation, but a focal relationship that uses a summation. So really what we want to notice is that when the regular equation uses a symbol, the focal relationship uses the opposite symbol. Okay? The other thing we want to talk about as long as we're looking at page 2 is we want to remind ourselves of these definitions. And so although they're on the back, they exist on your ellipse number 2 notes when we learned how to write equations for ellipses, so you can always have them side by side if you need something. And these definitions are true whether we're working with an ellipse or a hyperbola. And one of the things you're going to hear me continue to emphasize as we go through the material and kind of wrap up the chapter in the coming weeks is that it's very important to pay attention to which conic you're thinking about. So you can't say, is A bigger? Because A is only bigger in an ellipse. A is not necessarily bigger in a hyperbola. Okay, so we've got to pay attention to that. But what does stay consistent, thankfully so, are these definitions. Now, I think for some of you, these definitions are not yet in your head. So I want you to ask yourself that honest question. Do you know, if I just had said in like a quick quiz, what's A? Could you have told me it's the distance from center to vertex? If so, you are in a good place. If you do not yet know that information, or don't know that B is distance from center to go vertex and C is distance from center to focus, if those are not things you could quote to me, if we were having a one-on-one conversation right now, then to be honest, you've got to get that memorized, because that's part of why writing an equation for you, and many of you, has been a challenge. Okay, I feel that the people that are doing most successfully, including what I was starting to see on the quiz that I've at least started looking at, is that these were the key foundation that allowed that success with equation writing. All right, so a couple other quick things I want to remind you of before we get started. In an ellipse, x is always first, okay? But in a hyperbola, as you know, x can be first if it's horizontal, or y can be first if it's vertical, when it's a hyperbola. In an ellipse, x always first. In a hyperbola, it depends depends on the orientation of the hyperbola which letter is first. We also know that a squared and b squared can change in an ellipse, but a squared and b squared are solid and they do not move. A squared is always first, just like it says here, a is first and then the positive squared term. So this is a really nice summary, but it's a summary that you need to get in your head and get memorized. All right, so let's do some examples.